Okay, so usual routine here. We need to read the question carefully at the outset. The diagram shows part of the curve with the equation and part of the line with the equation y equals x plus 6. Use an appropriate algebraic method to find the coordinates of A and B, which are the points of intersection. So we should know that where the lines intersect, the y values are the same. So we can go x plus 6 at intersection x plus 6 is equal to x squared minus 8x plus 20, x squared minus 8x plus 20. Well, it's a quadratic. How do we like them? Positive and equal to 0. So we get x squared, subtract the 8x, that's minus 9x plus 14. If in doubt, use the grid to factorise. It looks like it's x minus 7, x minus 2. So x equals 7 and x equals 2 at the points of intersection. But we're asked for the coordinates of A and B, so we've got to substitute them back in. So A is equal to, well, let's use the y equals x plus 6. So we get 7, and then add the 6 is 13. That must be B. And A, which is the left-hand one, 2 and 8. Written those down in the wrong order really, but it doesn't change the answer. Part B. Find the exact value of the area of the finite region bounded by the x-axis and the lines x equals A, x equals B, and the line AB. So that is what looks like the... Let's pick another colour. There's the line x equals A, there's the line x equals B, there's a straight line, and here's the x-axis. So we've got a trapezium there. Right, this is the h in our equation, the distance between the parallel sides, and there the parallel sides A and B. So area is equal to the sum of the parallel sides A and B times the distance between them divided by 2. So A and B are the parallel sides, they are the y values. So we're going to have 8 plus 13 times the distance between them, which is the difference between the x values. So 7 take away 2 is 5 over 2. So that's 21 times 5 over 2 is 105 over 2, or if you prefer, 52.5. Part C, or 52.5, if you've used a calculator. Use calculus to find the exact value of the finite region bound by the x-axis and the lines x equals A, x equals B, and the curve. So that's the area underneath. So that is this bit in here. Yeah, the area under the curve between A and B. So to do that, we know hopefully that we integrate. So we need the integral. So the area is equal to the integral. Well, it's between the x values, so that's 2 and 7. Yeah, it's coming from the same places that we had up here, 2 and 7, to give us these. Yeah. And we're integrating our equation for the curve, which is x squared minus 8x plus 20, x squared minus 8x plus 20 dx. Integrating, we write down the constant, which is 1, add 1 to the power, divide by the new power. Write down the constant, negative 8, add 1 to the power, divide by the new power. Write down the constant, which is 20, add 1 to the power of x. Well, x was 0, so it's now x to the 1 over 1, which we don't write down. We don't need the plus c because we've got limits. Let's tidy that up. So we've got x cubed over 3 minus 4x squared plus 20 lots of x between 2 and 7. This next line is really important to write down because we put this is usually in the mark schemes as being worth a mark. which is showing that we know how to substitute the limits in. So we get 7 cubed minus 4 lots of 7 squared plus 20 lots of 7 minus 2 cubed over 3 minus 4 lots of 2 squared plus 20 lots of 2. Notice each value time I've substituted in the limit, I've put it in a bracket. Now work it out, you can just tap it in a calculator. I'll get 343 over 3 minus 49 times 4, which is 196, plus 140, minus 8 over 3, minus 2 squared is 4, that's 16, plus 40. Tidy this up, we've got 343 over 3 minus 56 minus 8 over 3 plus 24. Well, let's deal with the thirds first. 343 minus 8 is 353 over 355 over, no, that's stupid, 345, we'll get there in 335, let's get there in the end. Subtract 8, 335 over 3 minus 56 minus another 24 is minus 80. Well, 80 is 240 over 3, so we've got 335 over 3 minus 240 over 3. So that's going to give us a total of 6095 over 3. Okay, so that's the exact value. We could write that as 31 2/3 if we wanted to. Okay, part D, hence find to one decimal place the value of the shaded region enclosed by the curve y equals x squared minus 8x plus 20 and the line AB. So now that is this shaded region in here that we're trying to find, and that's going to be the trapezium minus the integral dx, yeah? So the shaded region, D, the shaded region is equal to the trapezium, which was 52.5, which we did have 52.5, which was 105 over 2, 105 over 2 minus 95 over 3. Notice the way I've gone back to fractions. You can use a calculator quickly, but I'm going to get 315 over 6 minus 190 over 6, which is going to be equal to 125 over 6, which is 20 5/6. It asks for it to one decimal place, so if you tap that in the calculator, that'll be 20.8, I think. Okay.